Hi there, and welcome to the benefits of a feature model in banking. I'm Claudia. I'm a business analyst with KfW, a German government-owned promotional bank, and these are my co-authors, Richard and Bert. Let's get started. In the next 10 minutes, I'm going to tell you a few words about KfW and why and how we started feature modeling. I'll show you our feature model with its unique characteristic. On top of the feature model, we have developed a document generator which has a unique capability. A short summary will conclude the presentation. First, let me give you a little insight of our domain. KfW is one of Germany's largest banks, and our products are loans. Here's how we work. German ministries request promotional programs from KfW and give funds. Each program aims at a certain goal, such as environmental protection or renewables. A program is then designed by a KfW domain expert. Each program comes in several variants, and by further configuration, loans are derived. To describe a program, the domain expert writes a program information sheet. This is the main source of information for both borrowers and on-lending banks. It's important to understand what a KfW program is. A program is like a car platform in the automotive industry. On a platform, different car models can be built. A customer defines a car by configuring a car model. A KfW program defines different program variants. A customer defines a loan by further configuring a variant. Currently, we offer about 55 different retail programs with 300 variants, resulting in about 4,000 different loans. Each year, KfW grants hundreds of thousands of loans. We just have seen that programs are individually developed and maintained. So why did we start feature modeling? During the past 10 years, complexity of our portfolio has increased. New properties, values, and dependencies have been introduced. Program and software development costs have been rising. Time to market is several times longer than it used to be. Loan allocation and processing is complicated. To reduce costs, we needed to reduce complexity. This is really difficult because nobody knows all properties and all dependencies of all programs. And the program properties are not context-free, but influence each other. We needed a model that makes all the properties and dependencies visible and analyzable. For that, a feature model would be ideal if we regarded properties and their values as features. Feature modeling used to be completely unheard of at KfW. Nevertheless, we have built a feature tree from the program properties. A former colleague suggested to use the tool Feature IDE, so we did. To further restrict the superset of then possible loan configurations to valid loan configurations, we needed constraints such as housing program implies the borrower is a private individual. We could write these only after we had included the programs as features in our model. I guess this is highly unusual. Please remember though, a program is a class of products, but it did the trick. To show you a bit of our feature model, let's switch to our client-server multi-user configuration and analysis tool that we have developed on top of Feature IDE. Our tool is called YAP, Yet Another Product Configurator. The configurator is on the left. Please look what I can do now. This is the program subtree. The lower subtree contains about 700 program properties. By selecting a program feature, I can see underneath which properties are included in or excluded from this program. By selecting a property feature, I can see which programs include or exclude this property. Example, a farmer is not entitled to almost all programs, except these. We have developed some additional gimmicks. In the title bar you can see the from-to interest rates of all selectable programs. On the right, the program tiles are always in sync with the user's configuration on the left. And these are the benefits. We can now see all programs and all their properties in one model for the very first time at KfW. The feature model enables us to visualize and analyze exceptions and dependencies. Our domain experts can validate the correctness of the cross-tree constraints easily, because they know the program properties very well. YAP makes expert knowledge available to non-experts. If we give YAP to the ministries, we can show our orderers what kind of programs we can implement efficiently. Potential borrowers can configure their loans, choose properties in any order that they like, can't make mistakes in the decision process, and will always get a result. You know all this, don't you? But in the real banking world, all this doesn't go without saying. Now the document generator. Remember I said each program information sheet describes the properties of one program and is written and maintained manually? These documents should have the same structure and should describe the same facts in the same words, but this is really hard to achieve. In the slide you can see how paragraphs on the left and on the right correspond to feature groups shown in the middle. Normally, a feature model and a configuration are used to compose software, but you can compose a document too. So, if we provided text snippets describing the features, it should be possible to generate program information sheets, correct? Not quite. Off-the-shelf composer software doesn't exactly do this, because a program configuration is a partial configuration, which leaves many features undefined. We have to generate text from undefined features too, in order to describe all program variants in one information sheet. We have finally developed our own document generator. Basically, our composer concatenates the text snippets attached to the selected features in the pre-order of the feature model. But it also resolves the undefined features of the partial configuration during composition. Here's an example. On the left, you can see a cutout of a partial configuration with undefined features in green. In this situation, the composer repeatedly calls feature IDE and the set solver and determines the three permissible combinations shown in the middle. It then concatenates the text snippets attached to these features to produce the paragraphs shown on the right. The document generator also accepts a complete configuration, which exactly defines one loan. It then generates a fully customized loan description. Either way, the entire document will be composed of text snippets assigned to features. What are the benefits? Document generation enforces very uniform documents, meaning that all program information sheets share the same layout, document structure and style, and the same features are described identically. Changes to a text snippet are only made in one place and automatically affect all program information sheets. Document generation uncovers exceptional dependencies, which we recognize by the fact that appropriate sentences will not be generated. And, surprise, surprise, document generation is our number one standardization measure. We had not expected this. Instead of providing rules or guidelines which define a standard and ensuring that new developments comply, we provide tools that produce standard artifacts. YAP defines standard properties, and the document generator defines standard dependencies. I believe that the way we have built and used the feature model is unique. I also believe that it is unusual to apply product line engineering techniques in a bank, because we haven't found any other financial institutes which does so. And finally, everybody, if you know better, we would love to hear from you. Thank you.